Good afternoon and welcome. My name's Simon McCormack. I'm product management for Drut Technologies, and today we're going to talk about the Drut Software Platform. The DSP, as we call it internally, is a really interesting bit of software that you can use for building private cloud type infrastructure, and it's the base software we use for Drut's photonic fabric and disaggregated solution. What's interesting is you can run it as a standalone entity. So it doesn't always have to come with the photonic fabric. It can be a building block towards that. In the webinar today, I'm going to basically show an installation of the DSP and show how smoothly we can deploy this platform and the different components are part of it. Kind of an interesting thing to show a deployment, but we want to show how the bar to getting a private cloud setup can be very low with a DSP type environment, and it really help you towards building your own private cloud environments. Before I go into a demo, I want to do a few slides to tell you a little bit more about some of the components of the DSP, because there's a certain amount of Drut technology plus some open source technology. So if you're going down that direction for the open source, then this could be the platform for you. I'm working product management, so I spend a lot of time talking to customers about their problems and trying to build products so we meet the problems that these customers have. So I wanted to start a little bit about what's driving the problems that we see that's driving us building this software, because you'll see then the direction we're going and why we're going that direction if you think about some of the problems that we're going to describe. So I start off with this first slide of what do customers actually want from a private cloud type deployment. They're all looking, and you can say some have different problems, they all have different problems, etc. I'll say they're all looking for essentially a cloud-like experience. So they want their users, application deployment teams, to have a simple interface to deploy the machines that they're going to use for their service. We also think we can extend that kind of concept to all layers in your organization. So you think about people who are involved in your data centers. There'll be low-level infrastructure people, people deploying cloud platform, in addition to the application deployers and the users, etc. We think they all deserve kind of a cloud-like experience, something simple for them to be able to deploy what they need without worrying about the underlying infrastructure. That's a lot of what was driving people towards, I think, the public cloud, because that gave essentially a simple interface get into it. So that's the one core driving factor behind this software, is to try to give you that better experience. Now, there's a number of other things customers want. The list is endless, but I've got a few here. A lot of people are very frustrated when they're purchasing and they feel they're locked into technology solutions. So more and more customers we're finding they want more standards-based flexibility in the software stacks that they're deploying, which is where open source becomes interesting, because we've seen a lot of maturity in the open source software throughout the industry in the last few years, and I'm going to demonstrate some of that as I deploy the software today. Obviously, they still have high reliability and performance needs. HA is still high, none of that changed. They want control of costs. So one of the problems we've seen is customers getting unexpected bills in the days that they are today. And they also want a mix of public and private type services. So that in most cases, there's no concept that you're all public or you're all private. They want a little bit of a mix of the two, and security is very important to them. So I've got 6 kind of big bucket items about requirements here. And the big question is, why does public cloud not satisfy on its own? And what can you do with private cloud to meet some of these requirements? So my next slide, I talk a little bit about some of these needs. In the public cloud space, what we found is that it's continuing to be more expensive than people thought, and they're getting unexpected bills, which are ever increasing. And they find themselves essentially locked in. Once you've made that effort to move something to the public cloud, it's very difficult to bring it back unless you make it some kind of hybrid. People do have security concerns. Obviously, if they've got their own private data, you don't necessarily want to put it in the public cloud. And some they just won't migrate to the public cloud. It's just too much, too big, too difficult. And so the result is, in general, whatever happens, you have to maintain your own private clouds going forward. I think there was a lot of industry talk over the last number of years, particularly from the analysts talking about everything moving to the public cloud. And obviously that never made sense. I think the private cloud data center industry was continuing to increase quicker than the public cloud were, but all the press was about public cloud because obviously that was starting from a very small base. I think ultimately you'll always see both together, but you have to maintain your own private cloud to keep your business going up. But I mean, people still have problems with the private cloud, especially today in the climate today. It's, private cloud is not cheap. There's a lot of costs there, power, cooling, particularly with the new GPU type loads that are ever increasing number of power, ever increasing need for cooling that equipment, and not just withstanding the equipment that you need to purchase for these environments as well. So it's all very expensive, very complicated, because there's lots of components from lots of vendors being put together, and not everybody has the personnel to do this either. I mean, a lot of the times people have cut back on their resources, so it's very challenging. And we think there's a change in the traditional monolithic data center for enterprises. So the hyperscalers got these massive, bigger and bigger data centers. We know that. But for you as an enterprise, the type of data centers you have today may be different. Your traditional data center that you used 10 years ago may not have the power and cooling for modern equipment. Putting it all in one place may not even work. So a colo space distributed data center makes a little bit more sense. So you may have little pockets of data centers all connected with high-speed connectivity to make it all work. And I think this lends itself well to the Drut solution, because I want to be able to then deploy easily a new little private cloud. And that's what I'll show you in this demo today when I go through the product. Enough about requirements, what's driven us here. I think it's the primary message that I wanted to give there was basically, there's a continual need for private clouds in private data centers. They may be more distributed, so you need small little pockets of connectivity. And Drut actually has software that I think we can help you with this kind of situation. So the bottom line, number one thing is that we've got software that we can build for you. We can manage it for you, but we want to leave you in control. So using a lot of open source gives the control to you, because that open source you continue to take forward. So what we've done at Drut is, because why we built this software stack in the first place is an interesting thing to consider. With the Drut hardware, we had to build enough software to be able to use our hardware, right? The base level, and it's an infrastructure type software that we built anyway. And what we found is just that infrastructure software wasn't enough to validate our use case. So we built more software on top of it, more layers of software to prove an application works in a Drut hardware environment. So we built the software anyway for our own purposes. We showed that to customers. Customers purchased the software, and we realized we need to productize this solution because there's a lot of value to what we're providing. So I'll talk about the different layers of stacks of software that we have in the solution. My charts here I'm trying to describe. In the middle there, you see Drut Software Platform. That's really the underpinning software stack that we can use to bring all this together. And then below that, Fabric Manager, which is essentially optional. And then on top of it, services. I'll talk about why that's there in a moment. Start off with the Drut Software Platform. We basically have a hook into what I call infrastructure and hardware. So if you've got data center machines, you need to manipulate them at a hardware infrastructure level, bare metal type level, to be able to manage these machines, give them addresses, etc. So it's a bare metal type structure. You need software to do that. The DSP can do that for you. So you can purchase this solution in these different layers. So you could just use the DSP to do basic infrastructure of your compute environment, which lends yourself in the future to be able to add Drut Fabric as well. but you can continue on just using the Drut software. The next layer we optionally put on is that platform layer, hypervisor containers, virtual storage. So we've got the Drut software platform experience where we can simply deploy this containerized or virtual machine or virtual storage solution together, which is what I'm going to show as part of this demo. In fact, I'm showing 1 and 2 essentially today, the bottom 2 layers. Now, the next layers, cloud-like experience, apps and workloads become very customizable per install. That's where services come into it. I think every customer dreams of a cloud-like experience for their services. What they don't really realize up front is it's very difficult to do that for a vendor in a generic fashion. It needs to be customized to you. So you need services to do that, to really pin it all together. We can show examples and base structures, but you need something customized. Same for apps and workloads, which is why we have that layer built on top of it all. So the components we're typically deploying in the DSP. So there's a prime layer, infrastructure layer to DSP, which is typically fixed towards providing PXE services, image services, DHCP, DNS, networking, power management for devices, and also moves into the disaggregated GPU type environment. But then we have options on top of it. If you want to do cloud platform software on top with us, then we can take you down this journey of doing the open source Kubernetes, OpenStack type environment. You can choose different ones and you can do it yourself. See what I mean? We can give you a base platform that's basically the hardware deployed and networking figured out. You can then start deploying your own software on it, or you can let us do the next level, which is the OpenStack and Kubernetes piece. And then when you're doing something like OpenStack, you got to have a storage solution that kind of go together. You don't really have one without the other at this point. So Ceph is the storage solution of choice for us, although we can be flexible. The model we built allows plug-in modules to be able to be inserted, and you can do different technologies depending on what you want to do. On the left-hand side, you see networking, because we have a certain amount of networking that we'll build into the solution. Basic VLAN configuration, subnet configuration, and I'll show you a little bit of this in the demo. The right-hand side, the cloud experience is obviously, as I said, the services would tend to do that. And then workload application services. So my goal today in this demo is primarily an installation piece. I want to show you how we've built a playbook solution to be able to deploy the different applications. Once they're up, I do a little troubleshooting session on one of them to show how to get it up and running smoothly. And as I made some, let's call them intentional mistakes in my deployment to show how to troubleshoot the deployment mistake. We're going to cover more details on these applications in future sessions. So I'm going to do a deep dive on Ceph, do a deep dive on OpenStack. We can do the cloud experience portal and the other pieces, I think, as we go on. So zooming into the demo wise, and what I've done this time is because I'm doing deployment, it takes more than a couple of minutes sometimes to do deployment of software. And we don't want to all sit here where I did it live. So I did it in advance and videoed it, and I can play my little videos. But I want to start off with talking about what happens in a data center type deployment typically. Most data centers are already there. They've already got this function called management control, which is the DHCP, PXE boot image services already in the data center. They already got that solution. This solution here comes with its own management control solution. So how does that work? Well, we want to be able to mix the two together nicely so they can play well together and still be able to offer these different services. Now, if you remember what I said earlier on in the presentation, a lot of new data center deployments are little remote colos. What's interesting, there's remote colos, because I've done some of these. You turn up, there's a cage, the cage has a rack. There's no server in there for you to deploy your management control software onto it. There isn't an existing function. So you have to basically sometimes bring the management control software and put it together. So you almost have like a chicken and egg situation where I got to deploy my management control software, but I need something to deploy it, but there's nothing there to deploy it with. In this case, you can use a USB stick, pre-install it on a machine, or even in some cases, we use a laptop to deploy the first machine. the demo here, actually, I did a video of me deploying the basic machine. Just gave me a Linux machine on a bare metal. That's all I did. So I'm not going to even play that video because it just, imagine I start this whole thing. I've got one Linux machine on bare metal, and I'm going to use that to bootstrap this OpenStack Ceph environment. First picture I'll go on to is actually showing, it's a simplified view. I've cut a lot of it out to try and simplify it. So I've got my control management software, which is my DSP. That's just a Linux machine at the moment, and it's connected to my management switch. Not worrying about storage or data networks at the moment because we're just trying to get it deployed. We can talk about all that in another session as well. I think that's probably worthy of an hour, just talking about the networking pieces to plug all this together. So here I've got a Linux machine and I want to deploy the DSP. So I'm going to go into my video, or before I do my video, I want to talk about the broadcast domain. So you'll see I've got the way we set this one up is I've got my yellow broadcast domain and my kind of bluey green broadcast domain. I got two separate domains because I imagined I'm plugging this into an existing data center. They've already got management control functions. So I basically have that on a separate broadcast domain to my new function because I want all my new machines to boot off this DSP. So when they come up, they'll go Pixie boot, anybody out there, and they'll hit my DSP. They won't hit the legacy setup. Now, in my lab, I have hundreds of these management control devices. They're all over the place, which is why we separate it like this. You don't necessarily need to have hundreds in your places. But let's go to the video and we can see what he's doing. And I speed some of it up. So basically, I've gone in, I'm actually running an Ansible playbook that is the configuration and manipulation and installation of these machines. So it's basically, I'm on this Linux machine I've deployed. I've downloaded a file that Drut gave me, and I run this playbook. Throughout the rest of the session today, I don't need to manually download any more files. It's going to grab everything for me. So it makes it really easy. I just grab one file, put it on this Linux machine, and then ran it. And it's now doing the management control installation and setting me up for the rest of it. I'm going to be able to do Ceph and OpenStack from this system. If you've ever done Ceph and OpenStack, you're trying to grab packages from all over the place, installing different things, figuring out the versions. There's a lot of complexity behind it. I like the way they've done the open source products, and there's so many modules. You see this install's finished, which is great. I like the way they've done modularized it, but there can be a lot of different components because not everybody needs the same things. So we've curated this and put it all together. So this is me logging into our DSP product for the first time now. So I logged in as Drut, and it's saying DHCP is not enabled. Welcome to the solution, and wants me to answer a bunch of questions in the basic splash screen. And then I can go into some of the networking setups and do things here. You notice there's a bunch of networks already set up. So what it does is it actually read from the Linux machine. So the VLANs and networks that were set on the machine, it pulled them in and basically configured it. I think this solution that we have, the playbook solution, is its first version. We're going to continue to improve it. One thing I did is I went on this machine and created these networks and then plumbed it, and then they read them in here automatically. What I'd like is to be able to go in here and add it, and it push it to the machine, make it go the other way around, which is definitely within the bounds of possibilities on this. And there's a bunch of other little things that you do, but I've basically set up my my system that can do the deployments now. So I can move to the next setup. So in this world, I've got to do OpenStack and I'm going to do Ceph. I want to do Ceph first, get the storage layer built. Then I'll do OpenStack, and then it'll integrate the two together, running from these playbooks. And I don't install any more software. It's going to do it all for me, grab whatever it needs. Got all the packages there. Anything it updates, it will grab automatically. So this setup now, if you see, I've got these 3 new machines, my demo DSP 5, 6, and 7. They're connected to 3 of the yellow ports. Sorry, the graphic is a little bit funny, but trust me, they are connected to those yellow ports, so that those machines, when they turn on, can be detected by the DSP. So they'll boot and they'll do a Pixie boot, and it'll detect them. Now, if you've got a server that's not set for Pixie boot, you need to set it for Pixie boot. So it'll Pixie boot out of this port, change it in the BIOS. But once you set it so it'll Pixie boot out of this port, it'll be captured and it'll be controlled in this environment. You didn't even install an OS on these machines, a pure bare metal machine. you got straight from the factory. Let's watch the install. Left-hand side, you'll see actually I've got, here's my machines. On the right-hand side, I'm running my Ceph playbook. So the Ceph playbook is going to basically start grabbing the machines. Now, in this case, I told Ceph which machines to grab. 5, 6, or 7, I told it. I'd say, well, maybe I want, for the cloud-like experience, I don't want to tell you which machines to get. This layer we're showing you is layer below cloud-like experience. Cloud-like experience is a user that says, just give me the machines. I don't care what machines. And that layer would program this layer to do the actual installation. So here I say, deterministically do these machines. So it's grabbed these 3 machines, you see them on the left, powered them on. Once they come on, it's going to install the Ceph software. And then once it's installed the software and got the packages right, it's going to do the configuration and configure the Ceph cluster together. Right now it's waiting. See, it's going a little bit black screen. And I sped some of this up. This is not doing this in real time because we'd have been waiting a long time. But it's waiting for these machines to come up, to be active, and then it'll start doing the next session. So the playbook is pretty smart. It knows what's out there, can connect to things. It can wait based on looking for a status. If there's a problem or an error, it gives sensible errors. I've had situations where I told it the wrong machine. Like I said, DSP 8, and there is an 8. It just came back saying, you don't have an 8. And then you have to go and fix it, and you can just rerun the playbook. So it's found the machine. They're all in the right state now. So they're all in the right state. So now it's installing the software. So all I did to get to this point is I answered some questions basically to prompt it, because I had to tell it the machines, and a couple more questions were answered. So from the user perspective, it's pretty simple. Answer a few questions, run the script, and it does the deployment for you, really removing a lot of the headache for getting these kind of services installed the way they were before. So Ceph is there and up and running. And I know we've already had this question in one of the Q&As that we can see. So I think some clever person said, well, how do you know it's deployed right? Well, and actually in this case, I didn't deploy it right. I made a mistake. You do need to go in and have a look and run through validation steps to make sure it's correct. We've done a certain amount of that automatically, but I'd done something that only Ceph could tell you. So actually, I didn't mean to do that. I go actually to click on the next slide. Still didn't mean to do that. Oh dear. There we go. I found it. I go to the next slide. Is it working? So let's run this one, because this will take us through an interesting little ride about whether the Ceph working. This is me logging in for the first time, and I'll prove it because it makes me change my password when I log in. And I'm going to try and figure out, what's the health status, and how can we go about getting the status of the system to be healthy and everything working correctly. So I just wonder, I'm thinking out loud, is that our installation script can do a series of automatic checks at the end of it. And I think that would probably be a good thing. Just wait there and then it comes back and tells you. But in this case today, I logged into the dashboard. You see the dashboard's giving me a warning. If you see the charts in the bottom, it's talking about the PG status. It's kind of inside baseball stuff, a little bit about Ceph. Basically, you want to clean up the placement groups. These are actually, it says placement group positioning and too few OSDs. So the OSDs are the disks on the setup. I literally gave this setup 2 disks. It's only 2. I got 3 servers and I gave it 2 disks. And the minimum it needs is 3 disks. Normally you'd have dozens of disks. You're going to have lots of servers, lots of disks. Not so maybe. But I wanted to see if I could break it a little bit. And it's also an interesting exercise to see about fixing it. Now, when I did this over, I had a bunch of, you see, it's only used 2 systems, not 3 as well. So I got 3 servers, I only used 2 for disks. So I went about, actually, the first thing I did was add more disks. So I went to my servers, and in this screen, basically, it's showing us OSD 1. 6 and 7 as OSD 1. This is the disk thing. We're going to make that for 2 later, because I'm going to go to the system, add more disks. And this one is complaining about the PG status. It's undersized PGs, placement groups. It's where it puts all the data across the Ceph data store. So in general, I don't care about that stuff. So now here I've gone to my machine, I've added some disks, and you see it's got a third disk there actually. If I pause it a second, you can see that this third disk has been added in a ready state. So obviously adding disks is very dependent on the hardware you have, whether you can hot insert them or what. These particular Dells I was using, hot insert them, but I had to, this machine I had to reboot it and create a virtual drive on the system. And so having done that and rebooted it, jumped forward a little bit, it's basically added the new OSDs automatically. The problem was that actually I still had a replication factor as too high. The replication factor is 3. I've only got 2 machines that have got OSD, so I actually changed it all to 2. So that was my next step. So I didn't have enough port placement groups or OSDs, and I had the replication factor too much. Now you see I've cleaned it up, and it's all gone clean. So replication factor 2 copies of everything. PG status is now all clean. Go back to the dashboard and everything's good. So that was a quick method that I went through to try and troubleshoot it. I think what I want to do for Ceph is I'll do a deep dive on this where we go through this in intricate detail, because there's a lot of interesting use cases you can go through with your data and volumes and machines and the high availability of the whole environment, et cetera, that is very interesting. I just wanted to give you a feel. So you think about from that install where I did the video where I did the install through the playbook, that got me here. All I did was answer a couple of questions and it took me through the install and I got to the next step. So it was very easy to get into that position from the software. And I only downloaded the one package from Drut to kickstart the whole deployment. And I know I was slightly less on my disks, but I got that install up and running. Now the next step, I want to do OpenStack. So if you notice, I've got 3 more machines in my picture, 3 OpenStack machines now. So I'll do the playbook deployment of OpenStack, and then it's going to do an integration with Ceph, bring the 2 together. At the end of that, I'll be able to create a VM in OpenStack using the data from a volume from the Ceph setup. So I've basically got a fully functioning setup at that point. And all I'm going to do is run another playbook. So here I start off by actually looking at these machines. So I looked at the machines I'm going to do for OpenStack. I needed to tweak some networking for them because I want to do a little bit of network change to give the VMs access to the internet, because these obviously got external facing VMs. Now I'm doing them in the DSP UI. This is before machines are even turned on, so I'm kind of prepping it, which is a nice function. I then pointed my questions that I did for the playbook, I then configured locally, and the 2 were synced up together. I think an enhancement here is I can make one do the other. So if I do this, it should answer that question on the system for the installation, and vice versa. That's kind of the direction I'd want it to go. Now I run my setup OpenStack playbook, and it'll go off and do the same thing as it did before. Similar thing. It's going to grab the machines on the left, powers them on, deploys Ubuntu in this case. So it's deploying the OS from scratch. All I did was give it some bare metal machines, deploy Ubuntu, and wait for it to come back. It's happy with the machines come back. I was really quick on the fast forwarding this time. And then it's doing the next playbook. So it's basically got a series of playbooks here. And the next playbook is basically installing all of the OpenStack components. And with OpenStack, there's a lot of different components that you can choose, continue to add, and change them as you go forward. So there's a lot more pieces that it adds to the configuration. Once it's done that configuration, then it completes it by doing an integration. So making the volumes from Ceph available within OpenStack, so that as a user, I can create a machine, and from that machine, I want to give it storage. It's going to use storage from the shared Ceph storage environment, really making it simple for the OpenStack operator and giving you the basis, providing that cloud-like experience to the user, so they can create the machines and start installing the applications as and when they want. So you see, there's a lot of tasks it's running through in this particular setup. to get all this configured and put together. So it really is a huge time saver for an operator to be able to do this. Now we have additional playbooks to do more functions. So the next thing you say, what if I want to add another server tomorrow? Actually, we've got a playbook for adding a host. And I think I'll show that again in another session. Because this first time installs are good. This is a good basis to show you can get up and running. Sometimes you can get away with more complicated installs. Sometimes I'll give you a week to do the install if you're doing that in a data center and it's finished, it's set up now. Sometimes I'll give you a week to do the install. So you've got time to get it up and running. Once you're up and running in production or close to production, those luxuries are gone. You don't have a week to do anything now. Now you've got short windows. So those are the operations that are actually more interesting than the base install. But I wanted to do this one first because I want to show you how easy it is to get up and running with the DSP. Now I've got this software base that I can start building on top of and doing a lot more with. If I click the screen like that, it always takes me back to the video again. So in summary, I think what we want to describe for Drut is that we're really more than just a hardware component company. We've got a whole software solution, private cloud stack of software, which is all optional pieces that you can build in to offering cloud services for your environment. Depending on your needs, we probably got the software and we definitely have a lot of the hardware for you to be able to build a modern private cloud that sets you up for the future. And in a lot of cases, using open source standard type software that really puts you in control and not so vendor locked into other solutions. Well, that's all I had time for today. Thanks very much for joining. I will see you again in a future session. Goodbye.